In defining a laser, we have to...
Well, laser really is, perhaps the physics are complicated.
Well, I'm trying to think of a good way to...
A laser...
If you want to know about lasers, I have to tell you three important things. One, these are spaghetti noodles. Two, anything you wiggle fast enough gives off light. And three, this is a lasagna noodle. Light's made of waves just like radio waves. As a matter of fact, radio waves and light waves are the same kind of electromagnetic waves. White light is made up of a whole bunch of mixed wavelengths. You can prove that with a prism. The different wavelengths all get bent at different angles through a prism, giving those color fringes. Another way to prove it is with filters. If you filter out some of the wavelengths and let other ones through, you see colors. Depending on which wavelengths you let through and which wavelengths you block, you see different colors. Well, say goodbye to visible light, because now I have to talk about wavelength and phase, and it's almost impossible to visualize with light. So I'm going to use sound waves, because not only can we hear them, but I get to play with the oscilloscope. This oscilloscope will show 4 different waves simultaneously, and it will add them together. Watch what happens when I add these 4. Not only does it look strange, it sounds like this. Now, if I could add hundreds and hundreds and hundreds and hundreds of different wavelengths all together, this would be the result. Now, look at this. These two have exactly the same wavelength, but their phase is different. They both start and stop, or rise and fall, at different times, even though their wavelength is exactly the same. If I add those two together, watch what happens. The result can actually be smaller than the two things that were added together. That's because while one's on the way up, the other one may be on the way down, and they cancel each other out to a certain extent. Guess what's coming next? These two have exactly the same wavelength, and they're in phase with each other. They rise and fall at exactly the same time. If I add those two together, you get a big one. That's how lasers are different than ordinary light. Even if you filter ordinary light to be of all one wavelength, the wavelengths aren't necessarily in phase with each other. But a laser, whether it's a huge one or a little itty-bitty tiny one, all produce light of the same wavelength and phase. It's called coherent light, and that's what's responsible for the incredible power and precision in a laser. I wonder how they do that.